Welcome to the next in the JCI series, Conversations with Giants in Medicine. I'm Ushma Neal, and today I'm here with someone for whom I am a big fan, the modern-day microbe hunter, Dr. Don Ganem. After a 15-year focus on the biology of hepatitis B virus family, he turned his attention to KSHV, the herpes virus that is the cause of the AIDS-related neoplasm Kaposi sarcoma. His lab at the University of California, San Francisco was the first to cultivate and develop tests for KSHV. After nearly 30 years in academia, in 2010, Don left for industry and is currently the Vice President and Global Head for Infectious Disease for the Novartis Institutes for Biomedical Research. Thank you so much for taking the time to speak with me today.
My pleasure.
I would love to hear a little bit about what you were like as a kid.
I was kind of a geek as a kid. I grew up in northern Massachusetts, right on the New Hampshire border, little town. It's a suburb of a sort of grimy industrial town called Lawrence. Lawrence was a town that was a very big textile factory center in the late 19th and early 20th century. But it's, after World War II, when all those mills moved initially down south where the labor wasn't organized, and then later offshore, the city fell on really very bad economic times, and from which it has really never recovered. But so I grew up in a suburb of that town. And the interesting thing about the area was it was a little microcosm of American immigration. Every single wave of immigration sent a little pseudopod into Lawrence to work in those factories, and there were all these different denominations of churches in that town, and each church came from a different part of Europe and said Mass in the mother tongue. So my parents were Lebanese. Now my grandparents came in that wave in the early part of the 20th century. And there was a church in Lawrence that said Mass in Arabic, and there was another one that said it in Polish, and another one that said it in, three of them that said it in Italian, and a whole bunch of churches for the Irish. And it was an exact microcosm of American immigration. So I grew up in in a somewhat blue-collar type setting, although my father was a surgeon, and so we had a white-collar lifestyle in a blue-collar town.
So where during your geeky childhood did you start to kindle your interest in science?
Oh, that definitely didn't happen till high school. When I was in grade school, my favorite subject was English. I thought I'd be a novelist.
Is it true that you got an F in algebra in 8th grade for holding hands with a girl?
Yes, it is true. Not only, how'd you know that?
I read pretty
I got an F for holding hands with Ginny Harding in algebra class, which really took my mind off the subject of algebra. I only got an F one term, though. I did get my act together after a very stern talking to by my dad. But yes, it is true. I did get an F in algebra one time.
Sorry, I interrupted
and
you.
Her dad was the headmaster, so that was even worse. Good thing he didn't find out.
I interrupted you. So what was it that made you interested in science once you finally got to high school?
Well, when I got to high school, my first encounter with science was a very unhappy one. Freshman year, I took something called earth science, which is a combination of geology and meteorology. And the instructor was just terrible, and he was incomprehensible. So I passed it, but it was a joyless experience. And the next year, sophomore year, I took biology. And the biology course was spectacular. The book, which I think is out of print now, was written by a guy named John Kimball, and it was designed to be an AP level biology class. And it was a new book at the time. This is 1966? And this was the first biology text that incorporated everything about the molecular biology revolution, the structure of DNA. The whole thing began the way we teach biology nowadays, with the consideration of genetics and the chemical nature of heredity. And it was just unlike what had preceded it, which was a phylogenetically organized, drudge-bedecked tour of zoology and botany, and which is what I was expecting in the class, and it was just fascinating, really, really interesting. And so I fell in love with the subject right then and there, and I knew I couldn't get enough of it, and it motivated me to learn something about chemistry, which was what I took the next year, and physics the year after that. By the time I was finished with that course in my sophomore year, I pretty much knew I was going to be a biology or a biochemist or a molecular biology major. I just fell in love with that subject. And So it was partly that, and it was partly when I was I want to say a junior in high school, Watson's book on the double helix, his little story of the discovery of the structure of DNA was published. And my dad got it for me for Christmas. And I read that book, I just could not put it down. I read it practically in one sitting because it was the other piece of life as a, it was the first book that talked about life as a scientist and not just science itself. And of course it was very interesting. It was overseas, it was all very romantic. They were staying up all hours of the day and night working on this very difficult but cosmically important problem. And it was rivalry and jealousy and a lot of human drama, you know, and I just thought, wow. And plus there was international travel and, you know, and I thought, wow, this is just spectacular. What a life. And I just fell in love with that book and I fell in love with the idea of being a molecular biologist.
Did that cause you to reach out to Watson so that you could work in his lab as an undergrad?
No, that was an accident. So when I got to college, you know, I took freshman biology, and it turned out that my section man in freshman biology was someone I'm still very close to today. It was Bob Horvitz, who went on to win the Nobel Prize. He was my section man in Bio 2, and I remember him, and he still remembers me from then. So I was lucky. I had great teachers in the introductory work. Matt Messelson taught the genetics course that I took my sophomore year. By the time I was finished my sophomore year, Keith Porter taught the cell biology course. Then I rapidly was at the point where I could take graduate courses in biology and biochemistry. There weren't that many of them, by the way, at the time. Right? Molecular biology was a brand new subject. There were no textbooks. Everything was taught from primary literature, so it was really, really exciting. And I can't remember whether it was my sophomore year. I think it was the spring term of my sophomore year. Since I'd taken all the undergraduate courses, I took the shuttle over to the medical school and took John Beckwith's graduate course in bacterial genetics, and I absolutely fell in love with that subject. So that summer, after that course, I decided I would try to get a job doing some sort of microbial genetics, and because that's where all of molecular biology was back then. I mean, you were either working on LAC or Lambda, right? And so I went to see Wally Gilbert in the biolabs, and he, of course, had no time for an undergraduate, but he suggested I see somebody called Jeffrey Miller. So Jeffrey Miller was at that time an instructor. He was at what at Harvard was called a junior fellow. And he worked jointly for John Beckwith and Jim Watson, but in Cambridge, he was affiliated with Jim. So, he had trained as a postdoc with John Beckwith. So he was a true bacterial geneticist. And so he said, Wally said, go see Jeffrey Miller. He does spirited lac genetics. And his lab was right down the hall, and he was under Watson's larger umbrella. And so I willy-nilly became part of what was then called the Watson-Gilbert group, because Wally Gilbert and Jim Watson, Wally Gilbert had only recently emigrated from physics, you know, where he'd been a tenured professor. He gave up his tenured professorship in physics, started over as an assistant professor of biology, you know, in the Watson orbit to learn molecular biology because he was convinced it was the only interesting thing worth studying. And so there was this huge group that had a conjoint group meeting, the Watson-Gilbert group. And because Jeffrey was affiliated with Jim, I was a sort of adoptee of the Watson group. And that was a spectacular environment for a kid. If you really loved molecular biology, and that was an unbelievable experience, right? Because, I mean, all these people had passed through that lab. So Joan Stites had recently left, Mario Capecchi had recently graduated, and the people who were in that lab now were people like Jack Greenblatt, who went on to a very successful career in transcription, Bill Hazeltine, who went on to become a millionaire, Alan Weiner. Yeah, there were just tons of really spectacular people, Nancy Maisels, just dozens of them, Terry Platt. And there was an assistant professor in that group, Klaus Weber, was a very good protein biochemist. And so it was a great environment for me. And Jeffrey was in Geneva most of the time. Jeffrey had taken a job in Geneva after about 6 or 8 months of my working with him. So for the rest of the time, I was officially Jeffrey's student in the Watson lab, and we corresponded overseas. And basically, it was a very fun and interesting place to do science, and a great place to grow up in science.
So after that exposure to research, what made you decide you wanted to go to medical school?
You want to know the truth?
Yes.
Well, of course, being surrounded by all these very brilliant people and being only, 18 or 19, I came to the conclusion that I probably wasn't smart enough for this career. And I began to think about whether there was a way to do something with the molecular biology that I was learning that wouldn't put me in the middle of this environment forever. Like all kids, I was a little underconfident about whether I could actually succeed in that environment. And because I was already working on E. coli, I thought, well, gee. And because I knew a lot about medicine because my father was a doctor, I thought, well, maybe this stuff is more applicable to medicine. And there are ways to apply all this knowledge to medicine and to infectious disease and pathogenic microorganisms. Now that idea is a total commonplace nowadays, right? There's nothing imaginative about that idea. But back then, in 1968, 69, that is not where the center of gravity in that world was. But I became obsessed with that idea. I thought this would be a really great thing to do. And I realized that if I wanted to do that, I would have to go to medical school because I'd have to learn something about that. It's interesting because it was never my intention when I went to med school to be a doctor. I didn't think I wanted to practice medicine. I grew up around the practice of medicine. My dad was a practicing surgeon. And of course, familiarity with that world breeds a certain amount of indifference. I wouldn't say contempt, but certainly indifference. None of his other suburban medical colleagues were particularly inspiring to me. And certainly their lifestyle appeared to pale compared to what Watson had described in the double helix, right? International travel, adventure, discovering previously unknown things. That just seemed like a great life. And so that's how I came to this decision. I sort of decided that if I went to medical school, I would either wind up doing pathogenic, bacteriology, virology, infectious disease, or perhaps I thought maybe I could go and learn something about immunology. I was also quite interested in immunology back then. And back then, there weren't a lot of places outside of medical school where you could study immunology. And so I resolved to go to medical school, but not because I wanted to be a doctor. At the time, it was all about lateralizing to learn about human biology and medicine so I could study infectious disease.
But you did decide that you enjoyed the patient care portion of.
Yeah, well, that's what happened when I got to medical school. Is in the third year, so when I went to med school, I did the first 2 years, and then the summer after my second year, I took a leave to work in the lab, and that was in a virology lab. I worked on SV40 DNA replication, because I knew I wanted to, by that time I'd made a decision that I was going to work on some eukaryotic infectious disease. And so I thought I'd better learn how to grow cells in culture and do molecular biology. And if you want to do molecular biology in eukaryotes in 1970, that pretty much meant you were going to work on animal viruses. So I worked for a young guy named George Fareed, who was working on SV40 DNA replication. And I had a blast. I worked there for 18 months, and then I went back to medical school. And when I went back to medical school, I actually discovered, to my surprise, how much I really enjoyed the wards. I loved taking care of people. I loved the intellectual puzzle of diagnostics. I thought, that was really much more interesting than I had suspected it would be. And I just fell in love with it. And so when you're a fourth-year student, in your heart of hearts, you're not really a doctor, but you're still being called a doctor. And that idea was profoundly unsettling to me. And I thought, okay, I've started this thing. I'm going to see it through. And so I decided that the only way to be sure I could really do this job was to pick a really difficult residency. And so I decided to stay in Boston at the Brigham, which was a very good residency, but also known to be a hard one, because I needed to prove to myself that I really could do this job. And that was just an exhilarating thing to do, to be a resident. I love being a medical resident, even though it was very, very hard. I just loved my time as a resident and got totally bonded to medicine, to clinical medicine during my 2 years at the Brigham.
And then you still decided to do some postdoctoral research.
Oh yeah, no, that was always a given, that I was not through with my science training, that was particularly because of all those years that had elapsed between when I worked on SV40 and when I returned to the world of science. So, by the time I was finished my first few rotations as an intern, I knew for a fact that I was going to see this all the way through, not just through the medical residency, but through an infectious disease subspecialty training, and that medicine was going to be part of my life. But I also knew that research was going to be the bigger part of my life, and that I had to get back and be a postdoc, because a lot of stuff happened between when I left the lab in '75 and when I came back into the world of science in '80. I mean, when I left the lab in Boston, we had to make our own restriction enzymes. And there were 3 or 4 that you could choose from, because you had to make them and purify them yourself. But by the time I came back, DNA sequencing had been invented, restriction enzymes were commercially available. The whole field had just moved so dramatically and rapidly. And molecular biology, which had been a little specialty niche when I was a student, it was now the language in which all of biology was clearly destined to be spoken. And so I had a lot of catching up to do, and I decided I needed to go to a first-rate lab, but this time, not just as a training exercise, I needed to go somewhere where I could work on the kind of problem I wanted to work on with somebody of the caliber who could teach me and get me back up to speed to where I needed to be, and that's how I chose to go to Harold's lab.
And why HBV?
Oh, that was the product of a big exercise I did when I was an intern. Because by the time I finished working on SV40, I knew that there was no point, continuing to work on just DNA replication per se. The next problem I was going to work on had to be something having to do with human disease, and it had to be from a human pathogen. That was the whole logic of going to med school in the first place. It's true that I fell in love with clinical medicine, but I didn't abandon the logic of my, going there to learn about pathogens. And so I was convinced I was going to work on a pathogen. Now, you have to realize, in 78, 79, when I was applying for postdocs, most animal virologists were not working on pathogens. They were, for the most part, working on, SV40, polyoma, or at least all of the really good ones. Some of them were working on influenza, but, there weren't a lot of choices. And I decided it was more important for me to go to the lab of a first-rate virologist and see if I could talk him into letting me work on HBV than to go to a lab that might already be working on HBV, but that I wasn't, mesmerized by. So I had heard through the grapevine that Harold was interested in hepatitis B, and I wrote to him, and I told him, because I always admired the work in that lab, what he and Mike Bishop had done. And I asked him if there was any way that I could go there not to work on retroviruses, but to work on HBV. And he said, sure, which was amazing to me. It surprises me to this day. But that's how it happened. And I was the first postdoc to begin working on HBV in Harold's lab.
And then you established your own lab as an assistant professor, still staying at UCSF, and spent the next 15 years figuring out pretty much everything about the replicative cycle of HBV.
I was lucky because I didn't really start my own lab on my own. Harold and I had an arrangement in which I would continue to satellite around his lab. I would be the prime mover on most of the HBV projects, but he still had a couple of postdocs, Christoph Seeger being one, who was working on very talented postdocs who were working on HBV. And so I was starting my group in the shadow of Harold's group. And that turned out, I know that kind of arrangement often ends badly, but in my case, it was terrific. And it ended well in part because Harold is such a great guy and such a gentleman, and a true scientist whose only interest is in science and not in self-promotion. And I've come to realize, just from inspecting my own career and looking at others whose careers have gone well, that there's a lot of postnatal development in this career. It's not like the minute you're an assistant professor, you're a fully formed, totally autonomous, ready to go, truly autonomous physician scientist. There's a lot of development that happens after your faculty promotion. I'm sure this is true for PhDs themselves, but it's especially true for MDs doing research. So I count myself lucky that I was not totally autonomous, that I had this period when I was able to develop my own scientific voice, but still have advice, example, and some resources, and the human resources that would flow to me from Harold's inbox, postdocs he just couldn't accept. So it worked out great for me. Now, is this a model for developing other physician scientists? Maybe not, because it requires that the senior partner be extremely generous. And generosity is a commodity that has always been a little bit in short supply in academics, and now is in very short supply because of the tightness of the science budget. It's difficult for people to be generous now in the way that Harold was generous.
I want to skip ahead just a little bit. At the height of the AIDS HIV pandemic, you were living in San Francisco, doing excellent work on HBV, but you decided to switch to KSHV.
Yeah.
Why?
It's a bit of a long story, but I'll try to give you the 60-second Shakespeare version. Right? This began when I was at a meeting in Madison, Wisconsin in the late 80s. There's this organization called the American Society for Virology. It's a professional society of virologists. And there's an annual meeting, and it's a very good annual meeting in one regard, that there are plenary sessions in the morning and then posters and short talks in the afternoon. And the plenary sessions are always given by very senior figures. And they tend to be overviews of not only current research, but also in the context of what's gone on before. So the plenary sessions are always extremely well attended. And I was very dutiful about going to ASV because it also helped with my graduate teaching. Because if you wanted to know what was the latest thing going on in influenza, you could just go and hear Peter Palese on the podium. And so I went that year, as I had every year. And that year, I was particularly struck by one thing. I was in my 40s by then. And so maybe it was early 1990. I remember being about 40 or so at the time. And I remember on that particular meeting, all of the plenary session speakers were people who had been very influential when I was in school, in medical school and undergraduate. And many of them got up and gave talks that were still about the very same problem that they had been working on when I was a kid, And I remember, and what was striking was it was one after another of these people by this time they were all in their mid to late 50s, very accomplished, but they were all still working on the same protein that they'd been working on, asking variants, more refined variants of the same question. And I remember just being struck by that, especially compared to the example that Harold had set, where he'd started out working on RSV, and then it started lateralizing to a whole series of other retroviruses, different aspects of the retroviral life cycle, initially reverse transcription, later integration and oncogenesis, and then off into hepatitis B, and later, he was even at the time experimenting with telomeres with Tizia delonga. And I saw, on the one hand, this example of somebody with a restless intellect and taking on new challenges. And then I saw the opposite profile on the podium at ASV. And I remember walking out of that amphitheater at the end of that meeting. And I couldn't figure it out, but something was wrong. And I was like upset. And when I got on the plane, I realized what it was, is that I did not want, at the age of 50, to be working on the self-same thing I was working on when I was 37. And I wanted to make sure that did not happen to me. Because I could already see at the time the forces that tell to make people go in that direction. You become a bigger and bigger fish in a smaller and smaller pond. Grant money becomes more and more assured. And it's easier to maintain that than it is to take a risk and do something new. And all around me at UCSF were the opposite kind of people who were taking risks and doing new things. And I thought, at that moment, I kind of had an epiphany in the plane. I began to ask myself on that flight, which, by the way, was a long flight, because even though Madison isn't that far away, you had to go through Chicago, wait around in O'Hare, so it took me all day to get back to San Francisco. And I remember thinking on the second limb of that flight, well, okay, so what am I going to do? And I began to ask myself, what was it that I felt like I was born to do? What did I really want to do? And one of the things that I had always wanted to do was to work on a pathogen or discover a pathogen. And because we didn't talk about this, but another book that influenced me when I was a kid was Microbe Hunters, this old book by Paul de Kruif about the great bacteriologists of the 19th century, Koch, Pasteur, all those guys. And they were always my scientific heroes. They were what got me interested in microbiology in the first place. So there was this dual theme, the Watson book and Microbe Hunters. And I thought, I asked myself, well, what about what I'm doing on hepatitis B isn't in accord with that? Well, the virus was already known. It was already clearly linked to chronic hepatitis and hepatoma. So in fact, I was working on another replication problem. I wasn't working on an etiologic or a pathogenetic problem. I was working on replication. That was a new and very different replication problem and very complicated and extremely interesting. But I said to myself, you know what? I have to start thinking about what the next big thing is. And so by this time, the AIDS epidemic was well underway in San Francisco, and during my attending months on the ID service, we were seeing an awful lot of HIV and an awful lot of KS. And so I remember sitting on that plane on the second limb, and I made a list on the back of an envelope. That was a napkin, actually, from United, of all the diseases that I was pretty sure were going to be infectious, but for which no etiology had been established. And at the top of that list was KS. Okay. I still remember what number 2 was, which was Kawasaki's disease. Thank God I didn't choose that, because that is still an unsolved problem.
And things moved fairly quickly. It was identified as the virus that was causative, and then your lab was the first to be able to actually culture it in B cells. You developed the test for it that showed that it positively was the virus that led to Kaposi sarcoma.
Yeah, so let's be fair about the record. We were the first people to grow virus and to see it in the electron microscope, but contemporaneously there were 3 or 4 other groups that were working on making serologic tests, all of which involved using the kind of cell line that we had developed. And so Pat Moore and Yuan were working on a serology, Thomas Schultz in London, our group. Those were the 3 big groups that were working on, but there were several other groups doing it. But my reason for wanting to develop a serologic test was not initially to enable clinical diagnosis. The most important thing for me at the time was I wanted to be sure that this really was the agent of KS, because what was known at the time was the genome was present in KS tissue, but it wasn't known what cell type it was in, and KS is a very complicated histologic lesion. And furthermore, we already knew these patients were dramatically immunosuppressed. So we had to deal with the question of whether this was an opportunistic saprophyte or whether this was really the cause. Was it a passenger, a contaminant, a saprophyte, or the etiologic agent? And at the end of the day, what I realized was, at that moment, that the only way there was no molecular or cellular test that would discriminate those alternatives. One had to do clinical epidemiology. And that's what impelled us down that path, because I didn't want to spend the next 10 years of my life working on something that someone else would show was not the cause of KS. My interest was the cause of KS. So that's how I wound up doing the first epidemiology piece that I ever did. And so we used the cell line as the basis of an immunofluorescence test. And Dean Kedis, who was my postdoc at the time, set up a great immunofluorescence test and used that to screen patient sera from all the risk groups. Now, what gave us a big leg up here was, because I already knew that I was interested in this problem, we'd been stockpiling clinical material, identifying collaborators and serum samples, and mapping out what we would do if we had the good fortune to identify the genome of the putative virus. So I had already mapped this out in my head before we were there. Now, we didn't, Pat and Yuan identified the genome, or snippets of it anyway, in their initial science paper. So I already knew what the agenda would be if we had access to such a snippet. And so we were off to the races. But I would say those groups that I articulated, that all of us contributed to the story of it. And everyone, with one exception, came to the same conclusion, which was this was the etiologic agent, because the prevalence of KSHV exactly was superimposable on what epidemiologists had predicted the agent ought to do. It was common in people who were at risk. It was rare in people who were not at risk. It was not widely disseminated in the general population. And that experience was just a very addictive one for me, because that's the first time I ever did an experiment with human materials. Up until then, I'd been 15 years on the faculty and hadn't ever done an experiment with human materials
speaking of
or
that,
clinical investigation.
in looking over your CV, it seems like you went to vet school because you worked with ground squirrels, ducks, honeybees, mice, xenopus, woodchucks, horses, and parrots.
Yeah, that's true. But again, the whole impetus was to discover causative agents of diseases. Now, in the early experiments, in the hepatitis B field, we worked on squirrels and ducks because they had their own indigenous viruses that were just like human HPV, or very similar to human HPV. And they provided the first animal model and the first tissues that we could examine for replicative intermediates. But it was interesting because that experience with ducks and squirrels put me in contact with a lot of veterinarians and farmers and people in the world of agriculture. And if we are ever approached by somebody who wants us to look for a disease in an outbreak in an animal, we will do that. We will take that card every time. In fact, we're still doing it even at Novartis. We just solved the etiologic agent of an outbreak of acute hepatitis in horses that was linked to an exposure to horse serum that was given for botulism. And it turns out to be a flavivirus, a new flavivirus. So I've never lost my interest in veterinary medicine, but it wasn't the thing that got me into this game. It happened late in the game. But I am a big camp follower of veterinary medicine. This is an underappreciated field, and we ought to have more vet schools, not less, and they ought to be great centers of research because I'm now convinced for every human infection, there is a really relevant animal model, much more relevant than these contrived models that you see people making up where human pathogens are spritzed into a non-native host.
You brought up your new role at Novartis. So to me, it seemed like over our interactions when I was working at the JCI as a manuscript editor, that you were the sort of prototypical academic researcher. So what made you decide that Novartis and industry in general was the next logical step for your career?
Yeah. Well, I was the prototypical academic, and many of my colleagues were really shocked when I just let it slip that I was leaving. And I have to confess that, I always thought I couldn't imagine that I would ever retire as anything but a professor of medicine and microbiology. I mean, for most of my adult life, I thought that. And I'd been offered jobs in industry and turned them down before. But a lot of it has to do with this evolution we've been talking about. When you're in a company, in a pharmaceutical company or a biotech firm, the whole mission is to make new therapies, right? So, I mean, by the time I actually was offered the job at Novartis, I was 60 years old, okay? I mean, Mark Fishman called me the day after the week before my 60th birthday. And I was already kind of wondering what the next phase was going to look like. And I'd been on the SAB at Novartis for about 5 or 6 years, so I knew the organization quite well. I knew they had great leadership there and a very, very strong commitment to science. And in a company, the entire focus of the institution is making a therapy for a clinical problem, okay? In other words, science and medicine are exactly congruent in a company. Whereas in a med school, and this is sad, but it's true, even for a physician scientist, you're either living in the world of science or you're living in the world of medicine, but you're very rarely living in both worlds simultaneously. Whereas in a company, you spend all day long thinking about clinical problems at the atomic and molecular level, at the highest level. In my typical day today, I'll have an appointment in the morning with a crystallographer, and the next appointment might be with a clinical investigator, and then with an enzymologist, a biochemist, a molecular biologist, somebody from the protein expression group. But it's all in the service of the kind of problems that I had grown to love from studying medicine. In my case, clinical infections, bacterial, the design of new antibiotics, the design of new antivirals for a large number of different viruses, opportunistic infections, respiratory infections, hepatitis. And every single thing that I have learned over the 30 years at UCSF is immediately applicable to every single thing that I'm doing at Novartis, or that my group there is doing. And that is a very exhilarating thing.
What do you want to accomplish there in the next 10 years?
I want to make therapies, and it's really very simple. In our antibacterial program, I want to produce new useful antibiotics for multi-resistant gram-negative rods. And if I have my druthers, I want them to be members of entirely new molecular classes, not sixth generation cephalosporins or penicillins. Obviously, if we have to go down that road, we will. But the fundamental problem in antibacterials is that there hasn't been a new chemical class for over 15 years. Some would say 20 years. And before, the quinolones were the last really novel gram-negative antibiotic. And before that were the cephalosporins. And this gets to very fundamental problems that we have an ignorance of how small molecules get across the outer membrane. So I would love, in our antibacterial program, to generate and to systematically solve that dilemma and produce, a generation of new chemical entities that can be active. Will we be successful? I have no idea. We've got a lot of ideas that if I told you about, I'd have to shoot you, so I can't. It's a very ambitious goal, but it's extraordinarily interesting. It's just as interesting as anything I've worked on in academic science. And in the virology program, the challenges are different. There, we know how to make drugs that get into mammalian cells, so there's not a radically different problem in drug discovery and design. It's a question now of picking areas of clinical need, finding the right enzymatic or biochemical target, and successfully seeing it through. But I love the idea that we're making therapies for diseases that, for which I know as a physician there's an unmet need, and the patients really need these things. So I'm finding very inspiring about my new job. It's a very different job from a university, but it is edifying, inspiring, and fun.
What do you think is your next challenge, or what's your next vocation?
Well, look, I'm 63 years old. I could see myself doing this job for the rest of my working life. I would be a happy camper if I could continue to do this job for another 10 years or more, as long as I'm capable of it.
Then a different question. If you were not a medical doctor and a scientist, what different vocation do you think you might have chosen?
Yeah. Well, yeah, if I were not in science or medicine, I think I would have probably been a professor of history. My hobby is history, World War II history, history of Europe between the wars and after post-war Europe. I'm very interested in Soviet history and Russian history. I probably would have been a history professor or maybe a diplomat. I could easily see being a diplomat, although not in an era dominated by a Republican Congress.
All right, well, I just need to end with one small anecdote. I kept some of the emails that you and I exchanged.
Oh, no, you cannot read that.
Well, you had a set of prize-winning comments, confidential comments that I just need to read because you certainly have an interesting way with words. So this was just a quick note to explain the logic of your objection to the line of argument pursued in the paper. You said, imagine the following scenario. Martians arrive on Earth, and as they disembark from their spaceship, they notice a body in the bushes, bludgeoned to death by a golf club. From the striking result that they conclude that on Earth, golf clubs are weapons. As they continue to survey the planet, they conclude that country clubs are military bases, since at those sites, men armed with these implements regularly assemble, surrounded by flags, and conduct what appear to be highly organized group exercises. Conclusion, attack the country club.
Yeah, I remember writing that. I won't disavow it. And that was the logic train that was used in that particular paper, to associate one observation with an erroneous conclusion.
Well, it certainly seems like you have a way with words, so perhaps writing in addition to being a professor of history.
Yeah. Well, writing history would be fun, or writing biography would be great fun.
All right, well, thank you so much for spending this last hour with me. I
Thank
really
you,
appreciated it.